I've just got this new writing tool, and I'm started just practicing on it. What I want to do is make some physics videos. Maybe just to start off with something simple like Newton's second law, and considering a situation. So, and I can practice my writing skills as I'm doing it as well. So, let's get started. Let's have some fun. Let's just say that are we're on a date, and we've taken our date to the top of some mountain somewhere, and this is a really odd looking mountain, but let's just say we made it up here, and this is us. This is a terrible drawing, but like I said, I'm still learning this thing. And so let's just say it's you and your date, right? You're taking your date up here, and you want to impress your date, and say, and here's some mountain. It goes down into some valley somewhere, and you can say to your date, hey, I can figure out the distance, or I can figure out how tall this mountain is from the valley. Let's call it this distance here. Right? That's about right. We'll call this distance x. So you tell your date, I can find the distance, or I can find the height of this mountain from the valley, and all I have to do is do some simple calculations, right? So you know from your physics course that you can think of a free body diagram here. And I bet I can do a better job at this. Let me see. Okay, let's see if I can utilize some of my tools here. So I can make some free body diagram. And we can think of what forces are acting on, let's say, a rock, right? I decided that I'm gonna actually throw a rock down. So here's a rock here. You're gonna throw it. Okay, that's not right. That's okay. So you've got this rock here, and you're gonna throw it. Throw it down and listen to when it hits. So whenever it hits, the sound wave is going to travel back at your ear at 344 meters per second, and you're going to hear this thing. Now, let's consider this rock, right, for simplicity, to be some point particle, and let's not consider air resistance. Air resistance, for the most part, is negligible for, let's say, a rock, right? In this case, it's not a very far distance. And let's also not think about the sound, the time that it takes for the sound to reach back to your ear. Now, we have some simple system now. Let's say, let's think of our free body diagram, right? We have the force of gravity going down, and since we're not thinking about air resistance, we're not thinking of anything else, just the force of gravity, right? And then we could think of some equation to explain this, right? So right off the top of our head, we can say, oh yeah, from physics we have some equation that relates velocity, the final velocity plus the acceleration times the time. So the final velocity is equal to the initial velocity. So in this case, it's just the initial velocity. We're just considering the initial velocity in this direction here, and we'll just call it the x direction. We can call it the y direction, but it doesn't really matter, right? It's the x direction. And so it's the final velocity in this x direction is is equal to the initial velocity in this x direction plus the acceleration in this x direction times the time that it takes to hit the floor. Okay. Or we don't even have to think about, in this case anyways, we don't have to think about the sound that it takes. If we couldn't see off this mountain here, we couldn't see the bottom, then we would rely on the sound traveling back up to your ear. But if we could actually see it anyways, we could just see, when it hits the ground. Anyhow, so that's just a little side note. So let's think of the initial velocity. What is the initial velocity? Well, if it starts here in my hand and then I just sort of let it go here, right? Let's just think that we're sort of just tossing it off here. We're doing that, and the initial velocity in this case is just going to be 0, right? Now, the acceleration is what? Well, it's the acceleration of gravity, right? It's just g. So, and actually, in this case, let's just consider that the upward direction acceleration is positive, right? So that means that since gravity is going down, that this acceleration is actually going to be negative. So if I wanted to rewrite it, I could just say the final velocity is equal to the acceleration times the time. Okay, so now if I wanted to find the velocity here, all I would have to do is, whenever this thing hits here, the final velocity, right before it hits here, let's say right here, just this little tiny spot here, I could find the final velocity, right? All I have to do is, well, I already know that g is equal to 9.8 meters per second squared, right? So that's already known. All I need now is the time. So once I see this thing hit, so I start my stopwatch, right? And then once it hits, I press stop, and then I find some time. And so now I have left is v final is equal to, let's say, 9.8 meters per second squared. And some time, let's just say it took 2 seconds. And this is actually negative, right? I just forgot that. So we do our multiplication and we find that it's 19.6 meters per second. So the velocity is in the negative direction and it's 19.6 meters per second. Okay, so now what can I do with this? Well, I told my date that I can actually solve for how tall this thing is. Well, so then you recall from physics, once again, you say, oh, okay, well, we've also got this other thing. So the final velocity, this other kinematic equation, is equal to the initial velocity squared actually, let's not even think of this one here. Let's do away with this. We're wasting time, aren't we? We actually have some other better equation that relates the distance to the velocity and the time, the acceleration, and all that good stuff. So we have the distance here is equal to the initial distance plus the initial velocity, we just call that v naught times t, plus 1/2 a t squared. So we really didn't have to do this in the first place. I mean, this would be impressive, right? You can calculate the velocity. You can tell your date, how fast it's going right before it hits the floor. And then you can also say, all right, well, I can also find this distance. So let's do it. Let's say this initial distance is starting right here, right? It's right here, and right here is the origin. We'll just call this the origin. Well, it starts from 0, right? So then we can say, alright, well that's 0. So what do we have left? We have this V naught, which we also said V naught is 0, right? Because it starts off in your hand and then you drop it. So it starts from rest and you drop it. So this V naught is also equal to 0. And then we're just left with this 1/2 AT squared, but we said that A is negative G, right? So now we can just write it as negative 1/2 GT squared. So good, we're almost there, right? So now we want to solve. We want to plug these things in, right? 1/2 and then 9.8 meters per second squared. And by the way, notice how I included the negative sign right here. So I already said that G is negative, so I didn't have to put the negative sign right here. So don't get confused right there. And then we said that the time is 2.0 seconds. Excuse me. And so now it's evident, it's easy to see what's going on, and whether or not you can do this in your head or not doesn't matter. It's not too terribly hard of a calculation. But we can see when we do the calculation, or whatever, we actually see that, first of all, this is a negative distance, right? So if this is the origin, going this way is in the negative direction. Notice the acceleration is in the negative direction this way. The velocity is in the negative direction this way. So we should come up with something negative, right? As for our position. And indeed we do. We have this one negative sign. And it should come out to 19.6 meters, right? So it's, it's approximately, let's say, 60 feet or so. And hopefully that would win you a date or something like that, a second date, or it would just be impressive. I've done this many times before, and as I've advanced in my physics field of study, I've learned to include air resistance or drag, and it has a little bit of an effect. Not much, but for a situation like this, it doesn't have too much of an effect. Though there are other systems that it has a much larger effect on it. Anyhow, I hope you enjoyed this video. It's sort of me just having fun with it, and well, catch you later.